All right, today we're diving into a breakthrough that could completely change our relationship with the physical world. It's a new AI model for robots called Pi-Zero, that's Pi-Zero, and believe me, it's a massive step towards what scientists are calling physical intelligence.
So to really get why this is such a huge deal, you have to understand this weird, kind of mind-bending idea called Moravex's paradox. For an AI, beating a chess grandmaster or calculating the orbits of planets, that's the easy stuff. But ask it to fold a simple t-shirt? That has been one of the hardest engineering puzzles ever. Abstract thinking is a piece of cake for them. Actually doing stuff is brutally hard.
The team behind Pi-Zero isn't just trying to solve laundry day, though. They're aiming for something much, much bigger. And they're inspired by this incredible idea from Robert Heinlein. See, the goal isn't to build a robot that's a one-trick pony, a specialist that just does one thing perfectly, like an insect. No, the real holy grail is to build a generalist, a machine that can learn to do just about anything.
And this slide just lays out the difference so perfectly. On the left, you've got today's robots. They're fantastic in a super-controlled factory, doing the same thing over and over. But change one little thing and they're completely lost. Now, on the right, that's the dream. A robot that learns on the fly, that can handle a messy real-world environment like your kitchen, and can pick up a new skill with just a bit of new data.
The key to making this dream a reality is something called a generalist robot policy. Now, the best way to think about this is to think about something like ChatGPT. That's a foundation model for language, right? You can ask it to do anything with words. Well, this is the exact same concept, but for physical action. It's one central AI brain that could power all sorts of different robots doing all sorts of different things.
So how in the world did they build Pi-Zero, this first real shot at a generalist robot? Okay, let's break down the recipe. It's a pretty fascinating mix of 3 core ingredients.
The recipe has 3 main parts. First up, an internet smart brain. They didn't start from scratch. They started with a vision language model, a VLM, that's already learned a ton about the world from all the text and images on the internet. Second, they gave it dexterity. They used this cool technique called flow matching, which basically lets the AI turn its high-level knowledge into really smooth, precise physical movements. And third, they gave it experience, and I mean a lot of experience.
You see, to build a generalist, you need to give it general experience. So they fed this model a massive and incredibly diverse dataset. It's a mix of data from their own robots, both single-arm and dual-arm, plus a big chunk of open-source data from the whole robotics community. This is what gives Pi-Zero such a broad, foundational understanding of how the physical world works.
And when I say a lot of experience, I am not kidding. The model was trained on more than 10,000 hours of robot interaction data. I mean, just try to wrap your head around that. That's like a robot working nonstop 24/7 for over a year, and all of that learning is condensed into its training.
Okay, all that theory and training data is great, but what can Pi-Zero actually do? This is where it gets really fun. Let's see what happens when the rubber meets the road. First up, the classic, almost impossible robotics task: laundry. Folding a crumpled t-shirt from a basket is so hard because every single crumpled shirt is a unique puzzle. It has a nearly infinite number of shapes. The robot can't just memorize a few moves. It has to actually see, understand, and adapt to the specific piece of cloth it's holding.
Next up, clearing a table. This is tough because you've got this huge variety of things, plates, cups, trash, and the robot has to know what to do with each of them. But here's the really mind-blowing part. The robot started developing its own strategies, things it was never explicitly taught. Like, it figured out that stacking plates was a more efficient way to clear the table. That's a sign of actual intelligence emerging.
And finally, putting together a cardboard box. Now, this is just a masterclass in dexterity. It takes 2 arms working together perfectly, reacting to how the cardboard is bending and pushing back, and it even uses the table as a kind of third hand to hold things in place. It's a dynamic, physical puzzle, and it's amazing to watch.
So how did it actually do? This chart here says it all. It compares Pi-Zero to the previous state-of-the-art models. The results are just staggering. Pi-Zero, way over on the left, is scoring almost 90% across the board. The next best models, they're not even in the same ballpark. Honestly, they barely even register on the chart. This isn't just a step forward, it's a monumental leap.
So, what was the secret sauce? What made the real difference? Well, this number tells the whole story. The full Pi-Zero model performed more than twice as well as a smaller version that didn't have that internet-smart VLM brain. So inheriting all that general knowledge about the world from the web, yeah, that was the absolute game changer.
So is this it? Have we solved robotics? Is the future here? Well, let's pump the brakes just a little. The creators themselves are very clear that this incredible achievement, it's just the beginning.
The researchers are really humble about this whole thing. They call it a small early step. They know there's still a very long and challenging road ahead to get from these really impressive demos to robots that can truly handle any task we can think to throw at them.
And the next set of challenges are even bigger, right? Researchers now need to figure out long-term planning, how to get these robots to learn and improve on their own, and how to make them more robust when they encounter something totally new. And of course, the most important piece of the puzzle, making sure these systems are fundamentally safe and reliable. Which brings us right back to where we started. For decades, Moravec's paradox has been this giant wall defining what AI couldn't do in the physical world. But Pi0, it really feels like it's starting to tear that wall down. We once believed specialization was for insects. The question this technology really makes you ask is, are we finally on the verge of building the first generalist machines?